This section is going to be about angles. So in order to talk about angles, if you think about it, our 5 previous postulates had nothing to do with angles. So we need a postulate to say how angles play together. And this is called the angle postulate, or postulate 6. And it basically says, I'll say it formally, and then we can talk about what it means. If W is a point on the interior of angle XYZ, then the measure of angle XYW plus the measure of angle WYZ equals the measure of angle XYZ. So I have that situation drawn here. So this is saying that W is a point on the interior of the angle XYZ. So the angle XYZ, those rays are drawn in black here, and there's an extra ray drawn through Y, that starts at Y, I should say, through W. And it basically says that the top angle here, XYW, plus the bottom angle, WYZ, the sum of those measures is the measure of the larger angle, XYZ. It basically says that you're allowed to add angles like that as long as they share a common side here. And that's really important for us to prove some results about angles that are coming up. So we will use this quite a bit going forward. Okay, I want to talk about a couple of special pairs of angles, relationships between two or more angles. I shouldn't say pairs, I should say sets of angles. And they are when angles are supplementary and complementary. And there's a little bit of a difference in the way that I'm going to do it and the way that the book does it. The book talks about supplementary angles and complementary angles being just 2 angles. However, I abuse the notation a little bit, and I can say sets of angles are supplementary or complementary. It just seems to make the arguments go a little bit better, and you can still really understand the idea. So for me, when watching these videos, when I say angles are supplementary, it could be 2 or more angles. Same with complementary. Okay, so supplementary angles are angles that have their measures sum to 180 degrees. You can think that, in fact, in most cases that we'll use it, we're thinking of this as breaking up a straight line. So that's what I mean by supplementary. Let me give you an example here. So here we have angle AOB and angle BOC. Well, there's a straight angle here, angle AOC, and by postulate 6, AOB plus BOC has to equal 180. So these 2 angles here, AOB and BOC, are supplementary. So what does that mean? That means if this angle measure was, say, 140 degrees, if angle AOB was 140, then angle BOC would be, well, 180 minus 140 degrees is 40 degrees. So BOC is 40 degrees, since these angles are supplementary. Complementary is a similar concept, but instead of adding to 180 degrees, they add to 90 degrees. So they break up a right angle. So for example, if angle XOY was 30 degrees, here's angle XOY, then angle YOZ would have to be 90 minus 30, which is 60 degrees. So you can check these guys. Angles AOB and BOC are supplementary, since 140 plus 40 is 180. And angles XOY and YOZ are complementary, because 30 degrees plus 60 degrees is 90 degrees. So just again, we see a lot of situations where we'll have more than 3 angles breaking up a 180-degree angle. So in my notation, I would say that angles here, A, B, and C, are supplementary. So that's how I use the word supplementary. A quick note, we're going to use supplementary a lot more than complementary. In fact, I don't think we use complementary in this course, but you will see it come up every once in a while in various textbooks. So it's good to know when you see the words complementary angles what it means. And one more key thing, I drew all examples here where you have a line breaking up either a 180-degree angle or a 90-degree angle. But that doesn't have to be the case. We can say angles are supplementary or complementary without them sharing a side or anything like that. So these two angles, 30 degrees plus 60 degrees is 90 degrees. So these two angles are indeed complementary angles, even though they don't share any side or any vertex or anything like that. All right, let's look at this example. So let's say we have 3 angles, and I just labeled them A, B, and C. I didn't bother calling them angle whatever, and that's fine. So I know 3 things about these angles. The first one is that A and B are supplementary. The second is that A and C are complementary. And the third is that the measure of B is 10 times the measure of C. So I want you to find the measure of each of these 3 angles. So pause the video and see if you can give this one a go. Write down each of these 3 things that you know as an equation and see if you can piece it all together to solve for all 3 of our variables. Okay, well, let's write down what we know here. If A and B are supplementary, it means that their measures sum to 180 degrees. And note what I didn't do. I didn't say that A plus B equals 180 because A and B stand for the angles. And we're talking about the measure of these angles, not the angles themselves. You can't, in some sense, add angles like that, but you can add their measures. So this isn't particularly a good way of writing that. Okay. So we know the measure of A and B is 180. We know the measure of A plus the measure of C is 90 degrees, since those angles are complementary. And we know the measure of B is, so equals, 10 times the measure of C. So the measure of B is equals 10 times the measure of C, 10 times the measure of C. So let's look at what we can do here. I'm going to rewrite this just with some variables to make it look a little bit easier. I'm going to call the measure of angle A x, I'm going to call the measure of angle B y, and I'm going to call the measure of angle C z. So the equations in their more familiar form would look something like x plus y equals 180, x plus z equals 90, and y equals 10 times z. So what I can do now, I have 3 equations and 3 variables, so I should be able to solve this. And I have a nice substitution already set out for me. I know y equals 10 times z. So where I see my y, I'm going to put in 10 times z. So let's go ahead and do that. So we're going to sub, label my equations here. So I'm going to sub 3 into 1. So let's do it. I know y equals 10z. So x plus y, which is now 10z since they equals 180. Okay? So let me write the second equation down as well, we have x plus z equals 90. So, I have this system of equations. I have two equations with two variables now, and I can solve this any way I like. And I automatically see elimination here as an easy way. I'm going to subtract equation 2 from equation 1. So let me subtract these guys. And I'll put the answer rather than below it, just because I'm almost at a space. I'll put the answer up here. So x minus x is 0. 10z minus 1z is 9z. And 180 minus 90 is 90. So we have 9z equals 90. Divide both sides by 9, of course, and we get that z equals 10. So we know the measure of angle C. Remember, the measure of angle C we called z. So we know that this guy, I'll just write it down here, this is 10 degrees. Maybe I'll use a different color so it doesn't bleed into that. I'll use blue. 10 degrees. Okay. Now that I have that, I can sub that into my equations and see what that gives me. And automatically it's going to give me the measure of B. So subbing into 3, let me scroll down to get a little more room here. So subbing into 3, we get that the measure of B equals 10 times the measure of C. But we know the measure of C is 10 degrees. There they are there. So that tells me that the measure of B is 100 degrees. Okay? So we have the measure of B being 100 degrees. And then finally, let's sub that into equation 1 to solve for A. Or we could sub it in to equation 2 to solve for A. So there's lots of different ways to solve for the measure of A here. So let's sub into 1. Oh, I want black here. Subbing into 1 now. I get that the measure of A plus the measure of B, the measure of B is 100 degrees. So 100 degrees equals 180 degrees. And all we do, of course, subtract 100 from both sides. And we get that the measure of A is indeed 80 degrees. So we put that up here, 80 degrees, and we found the measure of all three angles using the information that we had.